Hi, welcome to another video. So today I'm looking at the Texas Instruments dual non-inverting power driver. This little 8-pin device. So you put two signals in and you get two signals out. The propagation delay, so signal in to signal out, is 25 nanoseconds. So what I've done, programmed this microcontroller. This is a PIC 16F887. Right, this LED has been driven from timer 1 interrupt. If you're not familiar with timer interrupts, let me know and I'll do a video. The signal here, this is being turned on every 50 microseconds and it's staying on for 10 microseconds. And then this is in a while 1 loop. Every 2 seconds this stays on for 400 milliseconds. So that's just a while 1 loop, that's timer 1 interrupt. I've got these two signals running to the Texas Instruments high power driver. And if I turn this power supply on, you can see I'm running the power driver at 27 volts. So looking at the whole picture, you can see the two inputs, 5 volt inputs, through the high power driver, which is currently running at 27 volts. This is a 30 volt LED and that's a 12 volt fan. If you look at the blue LED, that's coming on every 2 seconds, driving the fan, and the white LED from the timer 1 interrupt, driving this LED. So unlike the solid state relay I tested a few months ago, this is obviously quicker. I'll turn the power down and you can see this is flickering on and off every 50 microseconds, but I'm getting funny effects on the camera, so we'll see what the video turns out like. I'll turn the power up now. That's now up at 30 volts. I'm getting odd effects on the camera here. So I've got the two devices to illustrate. A 30 volt supply driving two independent loads from two independent inputs. So this is the datasheet, and now the 8-pin device is this here UC3708. As you can see, dual non-inverting power driver, 3 amp peak current, 5 to 35 volt operation, 25 nanosecond propagation delay, so that's in to out. So this is the chip I'm using today. So I've got 5 volts for the enable, 2 inputs from the microcontroller, the common ground to the power supply and the microcontroller. I've got 30 volts here, and then you see the 2 outputs. Better still, if you look at this 16-pin device, you've got the same inputs, and then the outputs, you've got 2 voltage in for the outputs. So presumably you could have a 10 volt device and then a 30 volt device. So although it says 3 amps, that's peak transient, you can see, and the steady state is half an amp. So if you've got 35 volts in times half an amp, that's actually only 17.5 watts. And it says do not exceed the maximum power rating for the device, but they don't actually give a power rating. So in summary, you can drive two 35 volt loads, approximately half an amp, presumably that's split between the two. You're allowed a 3 amp peak transient current, all running off a microcontroller. You might have seen my video on a solid state relay that took a few milliseconds to turn on and off. If you're driving a load that requires fast switching and you're not just turning something on and off every hour or so, then maybe this is the better device. Thank you for watching.